So I definitely have these two in the middle. And then this one becomes minus 5 times negative 1. So now I've got 6 plus 5. Good. So I got 11 plus 39. And that's in the form A plus.
Okay, how's that come? 5, negative 5. How do you get that 5i squared down to what we did?
It's not x squared.
This is 5i squared.
Sure does. And what's I squared? Negative 1.
Right?
Negative 1.
Okay.
So complex numbers are, one reason we call them complex because they're freaky weird.
And then what is just I?
Okay, what is just I?
Very regular.
Yeah, so I is defined to be that, and that's the reason why I squared is negative 1. Because when I square both sides, don't I just kill the square root? So what am I left with? I'm left with negative 1. So it kind of goes counter to a lot of what we learned before now. We kept saying you can't square a number and get a negative. Well, you can't square a real number, and I always try to be careful when I said that. I always try to say the word real number. This is not real when he did the square root of negative 16, because now there is an answer. It's just not real. It's imaginary. What is the square root of negative 16? 4. 4i. It ain't 4, because 4 times 4 ain't negative 16. Just to show off my grammatical skills. What is 4i times 4i though? 69 squared, and I squared is negative 1, so you get negative 16. That checks, right? If you want to check the square root, you square it back and see what you get. Square root of 49 is 7 because 7 squared is 49. So that is definitely true because when I square it, I get back to what was inside. Okay. Yes?
Did you, I'm looking back at how you have that square and then you have a negative 45. If you just had that negative, square root of negative 16 there, would you pull out a negative 1 and then, you know, break it down? I'm just curious.
Sure, yeah, you could. Totally. I mean, that's, yeah, this is kind of like the idea behind why it is that way. This is the square root of 16 times the square root of negative 1, right? Square root of 16 is?
4.
Square root of negative 1 is? But I really want you to start going, I know we just got into this, but you can start moving in the direction where you don't even have to do that. If it's square rootable, if the square root of 9 is 3, the square root of negative 9 is 3i.
Just plug an I in.
Yeah. The I takes care of the negative part of the root.
Always, right?
Always.
So this only works with the square roots, doesn't work with cubic roots.
Yeah, it's funny you said that. Because in pre-calculus, we actually, well, here, let me show you one thing we can do. In here, we can't figure out what the hell that is. Right? Can you imagine trying to do the square root of I? I is freaky already. Square root of I, hello. Right? It actually comes out really nice, but the math to do it is really freaky. One thing we can do, let me see if I can get you guys with me here. Let's build up to it. What is 3 cubed? You're right there already, Jeff. 27. So what's the cube root of 27?
3.
See how those go together. All right, now watch this. What's I cubed? Who remembers what I cubed is? Isn't it I squared times I? So I cubed is negative I. Stop right there. So cool. All right, baby. So what's the cube root of negative I? If 3 cubed is 27, the cube root of 27 is 3. I cubed is negative I, the cube root of negative I is I. So we could do cube roots. I'm not going to make you. I just showed you because you happen to ask.
Can you hold on? Can you repeat what you said?
So this little piece makes total sense because it's still involving real numbers that we're used to. But you do the same exact thing. If something cubed is, if A cubed is B, then the cube root of B is A. That's really what that says, right? So if I cubed is negative 1, the cube root of negative I is I. That's a negative 1 there. If I cubed is negative I, then the cube root of negative I must be I. Just going backwards. Okay. Now, how would, let me just stop saying anything about that because that's beyond what we have to worry about. I just want to show you, because you brought it up with the cube roots. It's a really good question. But yeah, I can't do, why do cube roots not really bother me? What's the cube root of -8? No, can't be 2. No, it's not I. We've done this before. We even learned about I.
It's -2.
It's -2. Because odd roots, do they have problems with negatives?
No.
So don't suddenly think you have to pull I in all over when before we didn't. Math never changes. You just learn new stuff. It can't go back and change what we did before. Oh, now all of a sudden this is I. No, it's the same thing it was before. It can't be something new.
So it's only I if you're squaring it?
It's only I if it's a square root. Or even just an even root. But we're just going to worry about square roots here. Yeah. Okay, so the other question I had from...
Can you erase this one?
Which one? Sorry?
The I thing in the cube.
Here?
Yeah.
Okay. What can I do with this guy? This is coming right off of what we did right before the quiz. How do I do this?
Is that a math?
Conjugate.
That's a 9.
You multiply the conjugate?
Yeah, conjugate.
Yeah, exactly. Multiply by the conjugate. So not too bad. So you multiply by what?
7 plus
Plus
6.
6I.
So on the top you get
63 plus 54R.
on the bottom I get
7
49.
minus 6I.
good. And the middle terms I don't care about because they cancel, right? Minus 42 plus 42i, there you go. And then what's this here?
Minus 36 minus 1. Times negative.
So it's 49 plus 36, right? So negative 36 times negative 1 plus 36. Is that cool? So on the bottom I just get
48 plus 72.
50. Real quick, 50. If I make that 50, I got to make that 35. 85, easy. Right? That's how you add real quick when one of them's close to another number. Make it go up a little bit, and make the other number go down the same amount. Bam. That's it for the day. Okay. All right. Is it safe over here?
Yes.
Okay. So I think that's all the questions I know about. Anybody has any other questions yet?
In that answer, we can leave it like that?
Oh yeah, and remember, I think I said this the other day. I said if you leave it like this, I'm cool with it.
Okay.
But if you go one more step, it's not any more correct, but it is just verifying that it is in the form A plus BI. Exactly. Yes, sir. Yes, ma'am.
I have a question on that, the section that we went over, this 12.8. There was a homework question, the number 95. That was on page 787. If you want over that one.
What is it now?
The section 12.8.
Yep.
The first one was number 95. The I squared plus I squared.
Yeah. So, okay. Remember, I to the first is I. I squared is negative 1. I cubed is negative I. I to the fourth is 1. So then it starts over again. I to the fifth would be I to the fourth times I. It starts over. It's I. I to the sixth would be negative 1. I to the seventh would be negative I. I to the eighth was 1. It just keeps, if it comes back to 1, it's going to start over again. So it's the weird thing about powers of I. It's what we call cyclical. It goes through a cycle. So here's the cool thing about figuring out powers of I. If I ask you what I to the 48th power is, does 4 go into it evenly?
Yes.
Yes, so it's 1. Because every fourth one, it comes back to 1. Now watch. If I said
You
I
only
to
care about the
the...
first number?
Huh?
You only care about the
No, 4 goes into 48.
Oh.
So it's a 4, every fourth one, it comes back to 1. So if I said I to the 4004, that's 1. 4 goes into 4004. Every fourth one, it comes back to 1. Now watch. If I said, what's I to the 17th, that's 4 going to 17. No, but it's got remainder 1, so it's bam, it's I. If it was remainder 2, there. If it's remainder 3, there.
Oh, okay.
Kicks ass. It's because of the fact that it's cyclical like that. I just have to know, where am I in the cycle? Am I at the 4th one? I'm back to 1.
Do we have to know?
Is that going to be extra credit on the test?
No, this is going to be normal credit on the test. Yes.
So what about, there's one that said, I'm talking about that, there's like a negative I, the parentheses to the 71st.
Yeah, so we're building up to that. I want to
Okay.
make sure everybody's with me. We went through this the other day, and it seemed to me like everybody was decent at the end of this. Now it comes back to 1, so I to the 5th would just be 1 times I. So it starts over again at I. So I to the 6th would be I times I, which is I squared. That's why they're the same thing again. It's going to go back through the cycle. So because it starts over again at 1. 1 times I is I times I is I squared, so forth. And it goes back to 1. So where's it going to start over again at I9? I, right? I8 times I. What's I to the 9th? It would be I to the 8th times I. What's I to the 8th? 1 times I is I. It starts over again at I. Yes, sir?
How come I to 9 would be negative I? Because then it doesn't 3 go into 9?
That's not the cycle. How far does it go through a cycle? 4 steps. So it's all about the number 4 and how much does it go in. The remainder tells me where I am. Right? 4 goes into 8 perfectly. That's why it's equal to 1. 4 goes into 9 with 1 left over. I'm going to be there. And this is why that works. It's such a nice, easy thing. I can do 4 into a number and see what's left over. So what would I to the 71st be? What if 4 goes into, doesn't go into 71. So what number near 71 does it go into?
Negative I.
69.
Doesn't go into 69.
68.
68, right? Because it ends in 8. That's a good guess that 4 might go in. It doesn't go into every number that ends in 8. But it certainly goes into 68. So this would be
Negative I.
related to I to the what? So you can even write it like this. Isn't that the same thing?
Yeah.
Because 68 plus 3 is 71. So I could certainly just break it up like that. Why the hell would I do such a weird thing? Because I to something that's a multiple of 4 is 1. I cubed is negative I. And the quicker way to do it is 4 goes into 71 evenly with 3 left over, so it's equal to whatever the third dude is. That's it. That's all there is to it. You just think how many's left over when I divide 4 into it, because of the cycle it goes through. Please don't let that be a big problem. So like I to the 82nd. 4 goes into 82 evenly with how many left over? 2 left over. So where is it in the cycle? I squared is done. Yes, sir.
This might be a silly question, but if it only has 4 cycles, why are you going to do all 82 and all that?
No, it's not me doing it. It's if I'm working a problem out and I to the 82 comes out, I can simplify it because I know this. So I don't have the choice. I'm never going to do an 86. I don't know if the work I'm doing that makes that happen, right? So if it does happen, if I do get an I to the 82, I know what to do with it because of the cycle I do, right? So don't look at it, you can't control it. Just look at it, oh, thank God it cycles, so it's that easy to do it. I don't have to actually sit there and go, I times I times I times I times I times I. Screw it. Right? I got a really quick way. I can just break it down to one of these. Remainder 1, remainder 2, remainder 3, even. Only 4 values to know. Kicks some really big time ass. It's really nice. If you let it. Now, again, if you don't really get this, the most important thing to get out of this whole thing is this guy, because that's the one that happens the most often. Okay. Is there anything else in homework? Alright, so we're going to get back into section 13.1. Real quick little review. Oh, and who wasn't here the other day, didn't get the completing the square handout. Anybody else? Is that everybody? Okay. So a little review. Okay. Let's talk about trying to solve this thing. So remember, the whole idea is, if I can make this thing look like something squared equals a number, I can then just take the square root of it and get the answer really quickly, right? So that's the idea behind this completing the square method. So what are the 2 steps involved in figuring out the numbers?
It's the first one. Two, yeah. More.
So cut the middle dude in half, get 2. That's what's going to show up in how you factor this. No other way around.
8 divided by
2.
Oh, 8 divided by 2 is 40. What the hell am I doing? So that's what's going to show up in there. And the second step is, so you cut the middle term in half. My brain was trying to go ahead of me before I got there.
4.
8 divided by 2 is 4.
4 is square. Yeah.
16. And what does that number do? Where's that got to go? It's got to go right there. Now, if I add 16 here, I better add 16 there, right? We know that whatever I do to one side, I better to the other. I don't care where the 16 idea came from. If I add it there, I better add it there. You can't just go, well, this said to do it. Well, you put it there. You better put it there, right? Yes, ma'am.
And can we always do like shortcut and not shortcut like all square? So just like do 8 divided by 2 and then it's 4 and then 4 square which is 16, that's it?
I almost wore my other shirt today because I gave a test. So I was going to point to it and then I'm like, no, I got the wrong shirt on. So you know the shirt I'm talking about. Well, this is shirt. Okay. So what's on this side now?
16, 18.
18. So this here, the second step tells me what's going to have to go here. And does this factor like this? 4 times 4 is 16 and 4 plus 4 is 8. Now hear what I just said. 4 plus 4 is 8. That's why I cut it in half first. 8 was twice some numbers, twice whatever number was there. That's why this process will figure out what number has to go there to make this work. Because that's where 8 would have come from. It would have come from twice 4. Where would 16 have come from? 4 squared. Right? Because when I FOIL this, when I get 4 times 4 if I FOIL this out? Alright. You can tell that people are trying not to meet my gaze. Let's see. So if I have x plus 4 squared, what do you get when you FOIL it out? So what's this? So where'd the 8 come from? Looking at the original. Look at the original. 8 came from twice that. So if I'm working backwards and I know 8 but I don't know that, I'm going to cut it in half to get back to where it was, right? So going that way, I know it was 4. This is 4. And when I multiply it out, I get twice what it was. And the last number, whatever has to be here, is going to be the square of that guy. So if I don't know what that is, if I could figure out what it was, I know I've got to put the square back there. Well, how do I figure out what it was? Well, it's got to be half of that, because that's where the guy would have come from. So if I have x squared minus 20x, what would I have to put here? What's the 2 steps?
20 divided by 2.
Negative 20 divided by 2.
Minus 5.
minus 20. Then 100.
Yeah, and negative 10 squared is 100. So that 100's got to go where?
Upstairs.
It's got to go right here. And the negative 10 is how this would factor.
X.
So you actually have very little work to do. Now, if you forget that and you factor it, you're going to get that. Who cares? But if you realize the first step tells you what the answer is going to look like, that kicks so much ass. 2 things today kicked ass so far. If you let it. So how do I finish this out? Now that we've done that weird new process, why did that help me out? What can I do now immediately?
You don't FOIL?
No, if I FOIL it,
You put it into 0?
Square the 18.
Root square.
square root.
Square root. Oh my god.
Yeah, why can't I solve for x? Why can I not subtract 4 and start solving for x? Because it's stuck inside of a square, right? So I want to kill the square, get this thing free. Set it free. So you square root of the square, cancel. So your x plus 4 equals, so what do I have to put here?
Negative.
Plus or minus? Can you simplify this?
9
Yeah, square root of 9, square root of 2. Is that cool? Because that's what 18 is.
That's 3 square root of
3 square root of 2. Alright, now let me stop there for a second. Everything I just did is old news. I think I'm going too fast. It's a bad sign. You should be able to do that kind of thing really well. Simplify a radical. It's not a big deal. All the other stuff around it, that's new shit. That right there was old. And then how do I get x by itself?
minus 4.
Subtract 4, and I try to stick it in front so it looks a little bit more easy. Yeah, x. Minus 4, minus 4. Become a 3. There.
And that's that whole problem. That's what it pretty much wants you to do, correct?
Yeah, if I say solve this using completing the square, that's what I need to see. Because we're going to learn a shortcut, a major shortcut. Right? And this is where normally somebody goes, oh, that's what I always happens. So it's a long way. But completing the square actually has a lot of uses throughout a lot of different levels of math. So we're going to use it again several more times in the book. Without it, we wouldn't be able to do a lot of other stuff. Yeah.
You got me last month. I got the first way you cut it in half, and then the second step, whatever you get,
you square it.
Square it, and then I got lost after that.
Well then,
That was
okay,
easy,
so
right?
so this is the first thing you get is what goes inside. And the second thing you get is what needs to go here to make it work. So let's do a few more of those by themselves. Like we did here. All right, so same thing. The first step is what went inside. The second step is what had to go here. And again, I desperately, let's do some more of these, what I call motivational exercises here. What do you get if you FOIL this guy out?
X squared minus 7x minus 7x plus 49.
All right, everybody's cool with that, right? That's the easy way, because that's the way that you know everything. And that's why algebra is harder, because in algebra you don't know where the hell something came from. That's why algebra is harder. That's why it's more honest about life. All right. All right, now where did the 14 come from looking here? Just forget all that stuff. Where could you tell somebody the 14 came from? It came from twice that. So if I knew the 14, how could I figure out what that was? I could cut it in half. That's why the first step is to take the thing in the middle and cut it in half. You're figuring out what must have gone here. So half of negative 14 is negative 7. Make it normal areas. So that first step tells me what has to go in there. Why does it do that? Because that's what has to go in there. Period. There's no more explanation I could do. That's just what's got to be there to make this actually happen, because we just did it. We know what's got to make it happen. So what you do is you investigate a situation where you know everything and you try to figure out, well, if I didn't know this, what could I do? And then you can attack a situation where you don't know shit. And you're like, okay, I'm going to do the same thing I figured out over there. So the second step, once I know what that is, where did the 49 come from?
Negative 7
Squaring that number. So the first step I do is re-figure out what that number must have been. It must have been half of this dude, because that's where it would have come from. And once I know the number, I square it to figure out what number has to be there at the end of this trinomial to make it work. So let's do a couple more. And again, it's all spelled out on the handout I gave you too. So you always got that to refer back to. Not on a test. Don't get overly excited. So if I had x squared minus... we'll stick with nice numbers for now. We're going to do some uglier numbers here in a minute. What would I have to put here to make it factor like that? So what are your two steps?
Divide
Yeah, divide the guy in the middle by 2, and you do that to figure out what number must have been here. That's why the first step tells you what's going to be in your factored form, what's going to be in your answer.
X minus 6.
Yeah, so that's x minus 6 in there. Cool. So the first step told me that. So I didn't know what the answer is before I know what the question was, right? Because I don't know what goes here yet. So the second step is,
Minus 6 squared.
so now I know that 36 has to be, that's what makes this true. So only things that follow these rules can be factored like this. Meaning it would be it times itself. That's why I can write it. So it times itself. If it's it times itself, it follows these rules. So let's do another one where we use it to actually solve a problem.
We're going to do the problem in this one?
Yes, we're going to do another problem. So let's say I had to factor, or I had to solve this here. Let's make it minus 1. Dummy. Can you factor that? If so, I wouldn't be doing this. It's a problem. Can you factor that?
No.
Hell no, right? Factors of 3 are 3 and 1. Is it going to make 24? No. So the first thing I do, make some room here. Get that out of the way.
Oh, minus.
Yeah, get that out of the way. Because isn't it all about working with what goes here?
Yeah.
So move him out of the way. That's the first step. And again, that's on the handout also, that idea of the first step.
Minus 24.
Good. So then you do 2 steps on this complete a square. Negative 24 divided by 2. Negative 12. So that's what's going to go into what this is going to... So this is like little middle work. Is that cool? It's like right in the middle of all my work. So down here it's going to be x minus 12 squared. So what I don't know yet is what's going to go over here, because I've got to figure out what I've got to add here, right? All right. Yeah, negative 12 squared, 144. You notice how this is always going to be a positive number? Because we're not going to have complex numbers here. Don't freak out. That
So
would be
they're
so
always
easy.
going to be positive?
Yeah, this one's always going to be positive because we're going to have real numbers here, right? So when I square a real number, it always comes out positive. So if I add 144 there,
You have to add it in.
I better add 144 there. And we know that since we first learned solving equations. Whatever you do to one side, you better do the other side. So now I know that this guy, I already knew what it factored like before I finished him out. Factors like that. What's on that side now? 141. And why do you really almost don't care? I mean, 141, do you think that's factorable? It actually is. But how far can you go with it? What's 1 plus 4 plus 1? I don't know if you guys remember this. We talked about this a while back. If all the digits add up to a multiple of 3, then 3 goes into it.
Then 3 goes in.
What's 141 divided by 3?
3, 2, 21.
Yeah. 47. And is 47, can you go further with that? No. So the only reason I would try to actually break it up is if I get a square rootable number and some other, I get 3 times 47. Because what's the next step I'm going to take? Square root. So do I have to worry about trying to break this guy up? No, because it's 3 times 47. I can't do the square root of either one of those. So I'm just going to leave it where it is. Yes, sir?
So what we did now, we had a trinomial that we couldn't factor. We got rid of the part that we couldn't, that was missing up in factoring, right? That's what.
Yeah, so we got rid of him and replaced it with something better.
I see.
Because then if we do this, we get to this form where I can just directly kill the square. I couldn't do it up here. Good Lord, if you try to take a square root of this, forget about it. You can't distribute it. Nah, screw that. I got to put it into a form where the whole damn thing is squared, because now the square root kills it.
So it's just x minus 12 then.
Yeah, so then I get x minus 12 equals plus or minus square root of 141. And then to finish it, Finish it.
12.
Add 12. X equals 12 plus or minus rad 141. Yeah. So, I mean, we're finally getting to honest math where the answer, you thought that negative 29 over 7 was an ugly answer. And, you know, real life says, just wait. There you go. Right? So in real life, I can get who knows what kind of answers. They're probably not going to come out to be 3. Right? They could come out to be that thing. I love this guy. No regard for other teachers. That's all right. Okay. So how do we feel about that part of it? Let me show you one example. There's one example in the homework that's got... Notice how every single problem we've done... Remember how when we learned factoring, if the 1 was out front, it was easy?
Yeah.
Alright, so every single problem we've done so far has a 1 out front. In fact, completing the square only works if there's a 1 out front. So what do you think I do if I get something like this? Let's make this... let's not make this too equal yet, Jeff. Alright, we won't make it too equal yet.
You got times 2.
You're good. So first off, it won't factor. I checked that real quick, right? It won't factor. So yeah, keep the 5 out of the way. Well, this isn't so bad. How do you kill the 2?
Just erase.
No, how do you... Yeah, divide by 2. Now be careful. I always get people to do this. Why is that not right? Yeah, everything. There's no way that guy escapes. You got to divide this side by 2, which means both of those get divided by 2. So let's stop doing that. Nobody can escape. It's not fair. You don't get to pick and choose. Right? You're not God. Everybody gets cut in half.
Oh, because it has to be in the form.
Alright, first thing that looks like is a 5 halves. That's too bad. It's going to happen. So now, don't worry about that. I don't care about that side, really. Everything I do is about this. So what's my 2 steps?
Divide 6 by 2, and 3, then 9.
Good. So let's piece this back together. What's this 9 supposed to do? Yeah, it goes up here.
Then you add 9 to that.
Good. You better add 9 over there too. Or else you completely made a new equation. Right? You're not allowed to do that. And this 3...
It's X plus 3.
Yeah, so now this is going to factor like x plus 3 squared. And this, how do I add those together?
Common denominator.
Yeah.
2.
So you get 5 plus 18. Okay, I'm sorry.
23.
Yeah.
Now square.
So, as the, sorry.
No, he's right, go ahead.
As the answer, do we have to put like x squared plus 6, x plus 9 equals whatever is there equals like...
Well, sure. So we're now everything we did here helped us to rewrite this and then rewrite this.
Yeah, never mind. We are
So this you can even do it on the side. Maybe it's going to stick it in the middle. Maybe that's throwing people off. But I'm just working like I would any normal algebra problem. I'm just this here in the middle is just what I had to do to figure that out and to figure that out. Right?
Yeah.
And now that I've done this and I've got it in this form, I can do what?
Square root.
Take a square root. That's the beauty of putting it like this. Because now if I take a square root, put a plus or minus, the square root and the square cancel. Can you do the square root of 23 or 2? No, so you don't even care about it? I'm not going to worry about rationalization, don't worry about it. Yeah, subtract 3. So you get x equals negative 3. Yeah. Yes. So there is no way you can just look at that and go, oh yeah, I expected that. So you have to kind of let go of that. With easier equations, you can kind of say, oh, that makes sense, that makes sense. You can't just look at that and say, oh yeah, that makes sense. If you can, talk to me. I want you to teach me, oh master. We got plenty of time.
Hold on a second then, if we got plenty of time. Right there, the x squared plus 6x plus 9, and then you went to step 1 where 6/2 equals 3, and then step 2 it says 3.
Yep. Step 1 is cut the middle in half. Step 2 is square what you got. Right
Where's
there.
the square part from 3 at?
That's the second step. First step is cut that in half. Second step is square that.
Okay.
Because if I did x plus 3 squared, what do you get when you square it out? You get x squared
I'm in math.
plus 6x plus 9. 3 times 3, you get 3 squared.
Alright.
That's why you square what you get to figure out what goes there, because that's what has to go there. Yes?
I just have one question. For the 2x squared, when you start that, let's say if it was 3x squared, you still divide by 3 the
Of
negative?
course. If it's not 1,
You divide it by
you divide by it.
So,
In fact, you can just always divide by whatever that is.
okay.
Because if it's 1, nothing changes, so you're good.
But all
Yeah.
sides.
Sweet.
So, let me see.
So what about if that was, for example, it was 3x squared, but then the middle number was something that we couldn't go into?
All right, let's do two things, and then I'll let us out of here. Not before we get these two things done. Let's do one more example where the middle number is not nice. And then I want to talk really quickly about quadratic formula, and then we'll head out. Here we go. So let me just not worry. Well, let's see.
Dude, 30, bro.
Let's do, I'm not quite going to do what you're just asking for, just because that's a little bit uglier than I want to do for right now. So just a little bit. But, now, of course, what two things you have to do immediately? Yeah, I need to move the 4 out of the way,
Factor
And then
that.
divide by 3.
and then divide by 3. Of course, you can do that in the other order, who cares? So if I divide everything by 3, I get x squared plus 5x. Now, what's kind of worse about this problem than every other problem we've done so far? You can. It's just not going to go in evenly. But here, I want you to understand, because it's a very prescribed process, you almost don't care. I could put a 12.98 there, and you don't care. You cut it in half, and you square it. And you put those numbers in the right place. And it's not up to me to worry about that. The process is very prescribed. What do I do with this number?
5/2.
Cut it in half. There. Right? And then, what do I do with the answer? Square it. What's 5/2 squared?
25.
Yeah, I better not see any decimals unless it starts with decimals. If there ain't no decimals in the problem, I better not see any decimals in your work. Right? So what do I do with this 25/4? I'll tell you what you do with your 25. All right. So that's what has to go here. And of course,
Plus 25/4 of there.
there. And the 5/2 tells me how this factors. Can you imagine if I asked you to factor this? Would you like to do that?
No.
You don't have to, because that already told you how it factors, right?
X plus 5.
Yeah, x plus 5/2 squared. So I factored that because this guy told me how to do it. Thank you, dude. And if the worst part of this is adding those fractions, you can't complain. I don't want to hear it. Right? Before you can add them, you need to have a denominator, and that would be 12. So multiply by 4, and by 3, you get negative 16 over 12 plus 75 over 12.
70-something. Or
No.
60-something.
No.
59.
59, there it is. 15 from that would be 60. You take one more away, 59. And then you just square root. So you almost don't even care about that number, do I? And subtract the 5/2. So you end up here. Did that ending a little bit quickly, but I'm just trying to let us out soon. Okay. All right, so does anybody here already know the quadratic formula by any chance?
B plus minus square root of b squared minus 4ac over 2. To a.
I like it. real quick. This is the last thing we're going to do. Next time, I'm going to prove this to you. Even if you don't want me to. I'm going to prove it to you. Why? Where the hell that came from? It didn't just come out of us going, let's put some bees in there. It came from an actual place. It came from solving this equation with no numbers in it. So I'm going to solve that equation next time. But right now, if it's in that form, so tell me, for the one we just did, what's A? For the problem we just did.
3.
A is 3. B is
15.
C is
4.
4. So if I just plug the stuff in there, x equals negative 15 plus or minus 15 squared minus 4 times 3 times 4, because it's C,
Divided by 2
twice 3.
And it's gonna give you that same answer?
Yeah, it'll give me the same answer. It's just notice the 12. I could actually break it up as 4 times 3. I could go a little further with it and then rationalize it and all that stuff. So this will be the same exact answer, just in a little bit different form. That's plenty. You can just calculate this out. Not a big deal. What's a big deal is, if you've never seen this before, I want to show you where it comes from and show you it actually has a place that it comes from. Okay. Oh, maybe next time we get some new stuff. It's on the homework sheet. Yeah, 25th.